Lesson 1.4, Variables, Expressions, and Equations. Let's take a scenario. Let's say you have a basket, and in one basket you have 3 apples and 2 oranges, and in another basket you have 5 apples and 6 oranges. Well, how many would you have altogether? If you combined the baskets, you'd add your apples. 3 apples and 5 apples is 8 apples. And you'd add your oranges, 2 oranges and 6 oranges is 8 oranges. And so you'd say, I have 8 apples and I have 8 oranges. You wouldn't add them all up and say, I had 16 orples. Collecting like terms is the same thing in math. We only add things that are alike. You can't take 1 apple and 1 orange and say you have 2 orples. So we first need to learn how to identify like terms. Here are some terms, and we're going to categorize them by like terms. First, we're going to look at these, and we're going to say, okay, I have a 4y. What matches? 9y matches. And then if I have a 3, there's no variable, so what matches? Negative 16 matches. If I have a x squared, the 10x squared matches. And if I have a 2x, the negative 11x matches. Now you'll notice that I did not combine x squared and x. Those don't match. All of the terms that are in separate boxes are not alike each other. So I can't combine 9y and 3. Those don't go together. Only the 9y and the 4y can be combined. So now collecting like terms. When you're asked to collect like terms in math, what this is a process of simplifying and combining like terms together. So first we want to talk about the parts of the terms so we know what to look for and what to be combined. If you see an integer or a fraction or a decimal with no variable, that's a constant. Constants can be combined together. If you see letters, those are variables. They can represent any number and they can be any letter. If you have numbers that are attached to the letters, if they are in front of the letter, it's a coefficient. When you're adding like terms together, these are the numbers that get combined. If you have an exponent, the exponents attached to variables affect their alikeness. The variable and the exponent have to match perfectly. So if I have an x squared and an x to the third, these are not like terms. Only the x squared would be like another x squared. So here we have the coefficient in front, the exponent up top, and the variable is our letter. So when we want to talk about collecting like terms, we'll be given a string of terms in an expression. This can only be simplified, it cannot be solved. Simplifying and collecting like terms are the same operations. So first we identify the terms that are alike. 3x is the same as 7x. Negative 4y is alike 8y. 5 is like negative 10. Negative 2x squared is like 5x squared. Then it's sometimes helpful to rearrange them so that the like terms are together. But make sure that you keep the signs with the terms they belong to. So if there's a negative in front, like the negative 4y, or the minus 4y, it needs to stay with the 4y. So when I move these around, I put my x squareds together, my x's together, my y's together, my constants together, and my z, which is kind of hanging out by itself. Then I add the coefficients of the like terms together and I add the constants. Negative 2x plus 5x squared are going to give me 3x squared. 3x and 7x will give me 10x. Negative 4y plus 8y gives me 4y. 8z standing by itself gives me 8z. And then 5 minus 10 gives me negative 5. Some examples. I rearranged this to put the 3x and the 5x together, and then I added them to get 8x. This I didn't need to rearrange, so I just add the 7 and the 4 to get 11. This I rearranged so that the 3 and 8 are together, and I add those together to get 11. This one doesn't need to be rearranged. I add the 6x and the 2x to get 8x. If there is no coefficient in front of the letter, it's an invisible 1. So we count that as 3t plus 1v plus 1t plus 7v. I rearrange them. I add the t's together, so 3t plus 1t gives me 4t's. 1v plus 7v gives me 8v's. This, I rearrange, the 8 and the 7 go together, add those together to give me 15. Rearrange these to put the x's and y's together, add those together to give me 6y plus 12x plus 4. Now everything that doesn't combine just gets written back down the way it was. Here I'm rearranging to put my z's and u's together. 2x plus 14z plus 7u. And finally I'll rearrange to put my x's and y's together. 5x plus 2x plus 3y minus 8y plus 8. 5x and 2x gave me 7x. 3y minus 8y gives me negative 5y. And then the 8 just hangs out. Another important part of evaluating expressions and equations is to be able to convert from English to algebra. This is also known as word problems, which can be easier than you think if you understand what words mean operations in math. There are 4 major operations: addition, subtraction, multiplication, and division. We're going to start with words that mean addition. Sum, plus, add, and, total of, increased by, more than, raise, combined, altogether, additional, together, both, added to, in all, another. These all mean addition. Subtraction words include less than, minus, decreased by, more than. Now here's where it gets a little tricky. More than can mean either addition or subtraction, and you'll need to use context clues in the sentence to determine whether you need to add or subtract. We have difference, reduce, lost, left, remain, fell, dropped, change, nearer and farther, how much more or how much less, diminished, subtract from, fewer than, and words ending in er. Takeaway, only. Next we have multiplication. Of, times, multiplied by, product of, increased by, factor of, every, at this rate, in all, total, each, double, triple, and quadruple, words like that, per, as much, by. Next we have division, divided, quotient, split, each, cut, average, every and out of, ratio, shared, how many times, per, part, percent, which is to divide by 100. We have equality words as well. Words that mean equal include all forms of the word is. So is, are, was, were, will be. Yields, gives. We have greater than or greater than and equal to. We have is greater than, is more than, is greater than or equal to, and at least. And then we have less than and less than or equal to. Is less than, is fewer than, is less than or equal to, and at most. If you take down this list, this can help you with translating word problems into math. So let's try a few. 2 more than triple a number is 14. Okay, 2 more than. More than means to add. Triple is to multiply by 3. anytime you see something like this where it says a number, give that a variable. Is means equals and 14. So 2 more than 3x is equal to 14. We subtract 2 from both sides, and we get 3x is equal to 12. Divide both sides by 3, and you get that x is equal to 4. Here I have 2 more than 2/5 of a number is 6. Okay, 2 more than, again, so 2 plus 2/5 of. Of means to multiply. A number, give it a variable. You don't have to use x. You can use any variable you want. I'm going to rewrite this over here. Subtract 2 from both sides, and I have 2/5 x is equal to 4. Now I'm going to rewrite that here as well because there are 2 ways to solve a fraction. I can multiply by the reciprocal. These will cancel each other out, and I'm left with x is equal to 20 halves, or 10. Or I can multiply both sides by the denominator, and I'm left with the numerator, and x is equal to 20. Divide both sides by 2, and I get x is equal to 10. 9 less than 1/6 of a number is 2. Now 9 less than. This does not mean 9 minus. This is 9 less than, so we're going to subtract 9. 1/6 of a number and equals 2. So I need to rearrange this now so it'll make sense. So 1/6 x minus 9 is equal to 2. Add 9 to both sides, and I get 1/6 x is equal to 11. Multiply both sides by 6, and you get x is 66. Here's our last example. 4 less than 5 times a number divided by 3. Okay, 4 less than is going to be minus 4. 5 times a number divided by 3. This is a little bit tricky because are they saying to multiply 5 times x divided by 3? Or are they saying to multiply 5x and divide that by 3? Luckily, in this instance, it's not really going to make a difference if I say 5x divided by 3 or 5 times x divided by 3. They'll end up being the same thing, so we're really lucky there, and we can use whichever one we want. I'm going to go ahead and choose this one, and then I have is 11, so I have 5x over 3 minus 4 equals 11. I'll add 4 to both sides. And move this up here. I get 5x over 3 is equal to 15. Multiply both sides by 3, and I get 5x equals 45. Divide by 5, and I have x is equal to 9. Okay, here's some more examples of word problems. We have 3 of these. Okay, on Monday, 295 students went on a trip to the zoo. All 6 buses were filled, and 7 students had to travel in cars. How many students were in each bus? Okay, so we know that there were 6 buses, and we know that there were 295 students. And we know that 7 were in cars. Okay, and we want to know how many students were in each bus. Well, if we take 6 and we multiply it by an unknown number of students, that'll tell us how many were in a bus. And then 7 were in cars, and the total was 295. So we can subtract 7 from each side, and we'll get 6x is equal to 288. Divide both sides by 6 to find out that each bus held 48 students. Our next example, we have Oceandale's Oceanside Bike Rental Shop that charges $15 plus $8 an hour for renting a bike. Okay, so the way this works is you have $15 as your flat fee, and then you have to pay $8 an hour or per hour. So that's 8 times H. And Mike spent $79 to rent his bike. So we want to know how many hours did he rent it for. We can subtract 15 from both sides. 8H is equal to 79 minus 15, which gives us 64. Divide both sides by 8, and we know that the bike was rented for 8 hours. Next we have the length of a rectangle is 5 more than 3 times the width. Now this is very similar to the problems we just did. So first we're going to draw a rectangle, and then we're going to label the width, which would be W, and then we say 5 more than 3 times that, so that's going to be 3W plus 5. And we want to know what are the length and the width if the perimeter is 74. So remember, to find perimeter, we do 2 times the length plus 2 times the width. So I have 2 times 3W plus 5 plus 2 times W is equal to 74. So this is going to be 6W plus 10 plus 2W is equal to 74. 6W and 2W are like terms, so that's 8W plus 10 is equal to 74. Subtract 10 from both sides, and you get 8W is equal to 64. Divide by 8, and W is equal to 8 centimeters. The length is 3W plus 5, so that's 3 times 8 plus 5, which gives me 24 plus 5, which gives me 29 centimeters. The next kind of problem you'll have to do are consecutive even, consecutive, and consecutive odd number problems. Now, first of all, consecutive. What does the word consecutive mean? Consecutive means in order. Okay, so if we're talking about consecutive numbers and we just start with 5, we'd say 5, 6, 7, 8, 9, 10, etc. If we're talking about even, if we started at 2, 2, 4, 6, 8, and if we're talking about odd and we start at 3, we'd have 3, 5, 7, 9, etc. Now to get from a consecutive number from 5 to 6, I add 1 each time. So I add 1, and then I'd add 1 again, which means I'd have added a total of 2. And then I add 1 again, so I'd have added a total of 3. So consecutive numbers, if I start with x, the next one will be x plus 1, and then the next one would be x plus 2, x plus 3, etc. Well, I need 3 consecutive numbers, so I'm just picking the first 3. So I have x plus, because we're talking about a sum, x plus 1 plus x plus 2 is equal to 108. I have 1, 2, 3 x's, and then 1 plus 2 is 3. Subtract 3 from both sides, and I get 3x is equal to 105. Divide both sides by 3, and I get x is equal to 35. That would be the smallest of the 3 numbers. If I wanted to know all of the numbers, I would then just add 1 each time, so I'd have 35, 36, and 37. You can check your work by adding those numbers back together and seeing if you actually get 108. Now, the sum of 3 consecutive even numbers is 156. Well, if I start with x, and x was 2, how many numbers do I add to get to the next number? I add 2. And then I add 2 again, which means I've added a total of 4. And then I would add 2 again, which would give me a total of 6 that I've added, and 2 more, etc. But I only need the first 3. So I'll have x plus 2 plus x plus 4 is equal to 156. I have 3 x's, and 2 and 4 is 6. Subtract 6 from both sides, and you get 3x is equal to 150. Divide by 3 to get x is equal to 50. And if I needed to find all of the numbers, it would be 50, 52, and 54. I could add these together and see that they equaled 156, and I would know that I did that problem correctly. The last type is consecutive odd numbers. To go from a 3 to a 5 is similar to going from a 2 to 4. I add 2, and then I add 2 again. So consecutive odd and consecutive evens both require you to add 2 each time. So when I'm trying to find the sum of 3 consecutive odd numbers, it's the same setup as finding the sum of consecutive even numbers. So x plus 2 plus x plus 4 is equal to 93. I have 3 x's. 2 plus 4 is 6. Subtract 6 from both sides, and I get 3x is equal to 87. Divide by 3, and x is equal to 29. Consecutive odds would be 29, 31, and 33. You can add those together and see that you get 93. So you can check your work that way.